Hello, folks. I'm Nate, and I'm here to talk about some of the things that I find in Azure. I think it's important to start with sort of a chronology of how network security and network deployments have changed over time. I've been doing this for almost 20 years. I won't go into how long I've been hacking into networks, but what's really changed is back in the, as we were making progress through the late 90s, early 2000s, you had this idea that the internet exposure was limited, right? You had a team of guys that would make sure that this stuff, not just anything, was plugged into the internet. Today, cloud networking, pretty much any VM you turn on is going to be exposed to the internet because you're going to need to either RDP into it, SSH into it, or as you're going to find out later, there's some other terrible things that people are doing by default. The other thing with traditional networking is if you wanted to put things on the internet, you had to go through your firewall team, your router team, your certification team, and make sure that what you were doing was intelligent and you weren't opening up a hole into your network. Nowadays, a VM turns on and it comes with a predefined firewall that you may not even know is there, and you may not even know how to change it. The dedicated deployment teams was another good idea, right? You had people that actually knew somewhat about security. They made sure that your systems were patched, make sure that you're not running an old version of SQL or what have you. Today, you have a subscription in Azure or AWS. Anybody that has a subscription access can turn on pretty much anything they want, which you may not even know that this is happening. Once you have your old school network, your patching cadence. Obviously, I work for the MSRC, so every second Tuesday of the month, we release a bunch of fixes for you. Once you've got things in the cloud, your patch management becomes a bit decentralized, right? You may not know what you've actually got running in your IAAS subscription if you haven't been turning it all on or having total oversight into it. And then the other advantage is servers deployed from the ground up. Like I said, you make sure that they're secure before you put them on the internet. Today, when you go into an Azure Gallery or the AWS Marketplace, what you're turning on is a VM image that was built by someone else and uploaded, and it may not necessarily be up to date. And obviously, you only put the things that you need on the internet versus today, as I'm going to get to in a second, people will pretty much expose anything. So it's like we made a lot of progress, and now we're kind of going backwards. So this is what led us to 2017. These are most of the attacks that I started looking at. These are all the media that covered it. I'm not going to waste too much time on this. So NoSQL. This was the first one I started seeing back in August of 2016, and then in January of last year, it really took off as people started owning these things, right? These are quotes directly from the security pages of these different products, and I'm not trying to shame anybody here, but what I'm trying to illustrate is they tell you in their security page, don't put this thing on the internet. So of course, what do people do? Put it on the internet. So up till, actually, as recently as a couple weeks ago, these Mongo, Couch, Hadoop, Elastic, Redis, Cassandra, and a couple of other ones have been owned. What they're doing is dropping the database. They're not actually ransomwaring this thing, right? They put a ransom note in there. They'd say, hey, we have your data, send us some bitcoins, but there was no backup. There was no way to get this back. Globally, about 150, 180,000 machines were affected by this last year. In Azure, I think I'm up to about 3,000 that I've found of VMs that have been compromised like this. So I started thinking, how am I going to hunt this, right? As you might imagine, Microsoft owns a lot of IP addresses. At any given time, we've got about 1.6 to 1.8 million IP addresses that are open on the internet. The other thing about this many IPs, it's kind of slow to port scan this, and if I'm going to port scan 2 million IP addresses, and then a new attack comes out against a different product, I have to go and port scan the entire network again, which is really time consuming, obviously. The other thing about it is just because the port's open doesn't necessarily mean this thing's been compromised. Like, most of these products do have a way to secure it. With Mongo, you can turn on authentication. You can put IP tables in there. You can do something to try to make it a little bit better. So just because the port's open doesn't mean it's been owned. I need to actually see the database names. Like I said, they would drop the database, put a new one in there called DB dropped, or we have your data, or some other clever term. So how do I do this? I wish I could tell you I had a fancy solution that we wrote ourselves, but we don't. I use Shodan, and it turns out, as I was hunting these things, that it's accurate. We do have our own solution for some things. Shodan is just about as accurate, and the advantage is I can get a bunch of metadata. I can see other services that might be running on that IP address. I can also get the database names, and that's really key because that allows me to JSON export and write some code, which I did. So I was talking with a guy that runs Shodan and said, hey, you know what would be really cool? Instead of me having to do this manually, if we just had some code that ran inside Shodan that tags this stuff automatically for us. So he said, go ahead, write it. And I did. So wrote it. He added it to Shodan. This tag compromised feature now exists. And to date, it's found 22,000 pwned machines. Like, this is still ongoing, right? You'd think people would have figured this out to maybe stop doing this. But as of earlier this week, there's 22,000 machines out there that have still been compromised. So this does require the Shodan Enterprise API, and because I'm not trying to sell you Shodan, the code's available for free on GitHub. It's just a Python script. You run it against the JSON file, and it gives you a list of the IPs and whatever database it found that has been compromised. And I update it somewhat regularly as new attacks come out. So this got me thinking, did really 150,000 people all make the same stupid decision to put something on the internet with no password and no security? And what I started thinking about was, maybe this is an accident. Maybe this is something they don't know happened. Maybe they're deploying something and don't realize that it's insecure, which led me to look at the network security groups in Azure. So an Azure IAAS image comes with this network security group, which is a firewall that's set up by the person that uploaded the VM into the Azure gallery. So you can change this when you deploy. It's not a required thing. It's an optional field. You'll see it during the deployment, and if you want to look at it, you can, but it'll let you turn it on with as much or as few things exposed as you want, or as the person who made the image decided to set it up with. So going back to opening everything on the internet when you spin up a VM. Now, I can accept that management ports should always be open to a degree. 46% of the images that are in the Azure gallery have something turned on by default, right? So it's about 1,000, 1,200, something like that. The thing that's disturbing is 96% of those expose more than just a management port. The worst offender opens up 83 ports to the internet as soon as you turn on the VM. Yeah, and across all of them, I just counted up all the different ports. There's 562 different ports being exposed by all of the VMs across the board. So it's just an interesting thing that people are setting up this, hey, let's just open it to the internet when you turn it on and not tell people. To be fair, Amazon does the same thing. Now, I have a little bit less visibility into Amazon. Obviously, I work for Microsoft, but they call it an AMI. It's the same idea. Now, they don't give me the security groups in a way that I can see programmatically. So I haven't actually been able to pull all of the details, and I promise you, they do have it, though. This page right here is redacted so I don't shame the company involved, but if you use the one-click deploy, Amazon's going to fire up a VM with all those ports open by default. So I have filed a feature request with AWS in the interest of protecting customers and not just trying to say our cloud is better than your cloud, and they're being really cooperative and trying to help me out and give me this data. So Amazon's got 11,000 AMIs, and I suspect that I'm really curious to see what their attack threshold looks like compared to what we see in Azure. Finally, looking at all of the Shodan data and seeing all the people that have been compromised out there, what I see is that Rackspace, DigitalOcean, Alibaba Cloud, like pretty much any major cloud provider that offers sort of a cloud gallery image, has some of the similar problems that I've seen in Amazon and AWS or Azure. Sorry. So, like I said, industry collaboration. I'm not trying to shame anybody. What I'm trying to do is highlight something that I don't think people realize is a problem and work with other cloud partners to make this better for everybody's customers. So after all of this hunting for NoSQL stuff, I was kind of, okay, I'm good at it. I enjoy doing it. I like helping to protect our customers and was waiting for the next thing to hit. I didn't really have to wait very long, as it turns out. The shadow brokers, not to harp on a topic, right? There was an agency that had this really cool SMBP1 exploit, and I'm also on the team that runs the Windows vulnerability management stuff, so I got to see this exploit firsthand. It was really, really cool. So they put it in their Metasploit clone, and then like any good hacker team, they lost control of it. So, oh, whoops. So it turns out, unlike what I was a little surprised of, or what most of the people in the industry would be surprised of, is that we fixed this 2 months before, month and a half before they actually dropped the code, which most people don't think of Microsoft as being super proactive towards fixing vulnerabilities, but in this case we were. And it was really cool that, 31 days before they dropped the O-Day, we'd already fixed this thing. But I mean, at the point, nobody's going to put SMB on the internet, right? It's just not necessary. But as it turns out, they did. Once this tool came out, of course, the script kiddies jumped on it and everybody said, I've got this cool 0-day, let me just start blasting it across the internet. The thing that came with Eternal Blue was this implant called Double Pulsar. As any good agency has, you don't want to burn your precious 0-day more times than you have to because there's a higher probability somebody's going to catch it. So it allows you to do this test via a weird SMB error code At the time when this came out, there was only 14,000 IPs in Azure that had SMB open. So I couldn't check this the way I did with NoSQL, right? There was no database. There was no real indication this thing had been compromised. Fortunately, some guys from, I believe, NCC group wrote a really cool Python script that would do the setup, do the thing, set the command, look at the error code. So I just manually scanned all 14,000 of these things. I should have ended up adding this detection a few months later, but at the time we were trying to figure out how bad is this, what's our attack threshold. Turns out I was figuring there was going to be a lot more of these. We only had about 50 machines that have been hit with this. So you'd think, okay, 14,000, only 50 are implanted with this thing. That means everybody patched, right? And working for the Patch Tuesday team, we're like, sweet, we did something right, mission accomplished. Yeah, that wasn't actually the case. Couple bouts, let's see here. 28 days after the shadow brokers dropped their O-Day, the WannaCry virus hit. May 12th, it was a Friday, as one of our previous speakers had mentioned, and it was interesting to watch this thing take off across the internet. At the time, Azure had 14,000 VMs with SMB open, so we were fairly freaked out about what the damage was going to be here. This only went after MS-1710, and a lot of this has probably been discussed previously, but I want to highlight a few key things here. The initial infection appeared to be through an internet-exposed SMB port, imagine that, and it hit about 230,000 machines across a large part of the planet. The technology on this, though, I feel was rather low-tech. It was a really quick turnaround. I feel like a script kiddie wrapped something around an exploit that they didn't understand, tried to make some bitcoins out of it. And it really only had a propagation method of the same MS-1710 SMB exploit if you hadn't patched. So if you were patched, you were totally fine. A little while later, NotPetya happened. And NotPetya was interesting in that the Azure exposed SMB had gone up by 13% by the time this thing hit. So you would think after MS-1710, after WannaCry, after shadow brokers, people would have just said, nah, let's not put SMB on the internet. But I thought the same thing, and I was wrong. This was interesting in that it specifically targeted the Ukraine, right? They backdoored this MEDocs tax software. They put this malware into their update mechanism, and then it kicked off like Patch Friday, and everybody updated their tax software, and lo and behold, they were destroyed. The reason that I feel this probably escaped the Ukraine is from point-to-point VPN links, right? There's a fairly low probability that that this tax software is used much outside of the Ukraine, but the damage definitely escaped the country. It wasn't just them. This was a more high-tech weapon, right? It took a little bit longer before it came out, and the reason I think it's a lot more high-tech is that it used a bunch of propagation methods, and this was fascinating to look at when we realized this is using everybody's favorite tools like Mimikatz and PSExec, and then if all else failed, it could backdoor, you could use the Eternal Blue exploit. And the thing that made this really dangerous was that all you needed was one unpatched machine to get a foothold on, right? As soon as its foothold is there, all of your patched machines are going to get hit with a Mimikatz type attack. So this brings me to the point I want to make about IAAS security and the fact that it is your responsibility. Have you ever heard of something called ExpressRoute or Direct Connect? These are technologies that Azure and AWS have developed to allow people to connect their cloud networks to their on-premises networks. If it sounds like a VPN, it is. Mr. Jeffrey Snover here, he's not lying when he says we've spent a lot of time and money to secure Azure, but at the end of the day, your IaaS security is your responsibility, right? This is something you're deploying. It's like the old school model of my servers are mine, they're in my data center, I know where they are, except that they're not in your data center and you may not know where they are. And like I said before, you don't have as much oversight into what's being turned on if you have people just spinning up things in your subscription without your knowledge. So the managing ACLs on these peer-to-peer connections is tricky. If you pay the money, you can get dedicated IP addresses from Azure. I'm assuming AWS is the same way. The scary part is when I've talked to folks that have been like, yeah, well, it's really hard. Every time I reboot my VMs, I get a different IP address, so I just decided to allow like all of Azure's IP range into my corporate network. What? So it brings to the point at that point, is the cloud really any different than your own corporate network? And if you've done something like this, you basically just let anybody who has your cloud subscription open up your entire network to the internet at any time they want. And again, do your IT policies extend to your IaaS network, right? Do you know what's there? Are you patching it on a regular basis, right? But this isn't something that Microsoft will necessarily handle for you. Which brings me to the good news, is that we do have some stuff that we can help you with this, right? People, we hear this all the time. Patching causes downtime. It's really time consuming. We have other things we want to do. We don't really want to do this stuff. That's why we're in the cloud, because the cloud provider will handle all my patching for me. That's partially true. So the models of IaaS, PAAS, and SAAS are really perfectly illustrated here. If you're running with SAAS, we patch everything for you every month. It gets patched. I mean, we don't necessarily tell you, but it's all secured for you. We don't have to even think about it. If you're running with PAAS, you have to understand how to allow us to patch this stuff. And there's some concepts like failure domains, where you basically say, okay, I have a few servers. I want to sort of load balance between them. When you want to patch my PAAS machines, patch this one first, patch that one next, and that way you don't actually see any downtime. So it's not entirely seamless, but it is a way that you can just take that problem off your plate and not even think about it. It's a really cool way to do it, right? I come from an old school style of, we had to patch everything, we had to do everything, and then with cloud, it's advantageous to be able to deploy things quickly and not have to deal with, racking servers and doing all this other stuff. But you just have to think this through, and if you don't need to be using IaaS, there's not any reason to. If you can run it on PAAS or SAAS, it's a lot lower operational costs and improved security for you. So the other thing I want to highlight, we need to start thinking that these cloud marketplaces and these IaaS images should be looked at like a supply chain. As a few guys have said already today, supply chain attacks are common, or they're becoming increasingly common. Obviously, working for Microsoft when the CCleaner thing hit, it was freaky to see internal domain names listed in this thing. They're like, how did they even know that domain name exists? Like, that's an internal Microsoft thing. There's no reason that the cloud marketplaces wouldn't become a next place that people are going to look, right? You've got lots of resources, big machines, customers that are deploying in the cloud are going to be generally big businesses, right? So why wouldn't an attacker say, hey, let's go and see if we can Trojanize an IaaS image, or put some sort of a system in there that calls home as soon as they turn it on? That's one other point I forgot to make. Most of these, at least AWS and Azure by default, when you spin up one of these VMs or these IaaS images, it allows outbound connections, right? You don't get the option unless you specifically block the thing. So how hard would it really be to put like an interpreter callback and say, okay, turn on, call home to my C2, and then just have a guy that checks it every day and says, okay, let's see if anything cool phoned home today. The other point is some of these IaaS images can be really, really old. With Microsoft, obviously, we update the Windows stuff every month when we release new patches. I started looking at the age of some of these third-party IaaS images. There's a metadata in the APIs that tells me when the last time the thing was updated. In Azure, on average, these things are 123 days old. AWS, 2 years is the average. There's some that are older. I think the oldest I saw was 4 years old. So you're turning on something that's 4 years old. There's probably a couple of vulnerabilities that have come out since that thing was first spun up. And the other thing that's really important to remember is that when you patch an IaaS image, like if a vendor finds a malware and they say, okay, let's fix this thing, it's not going to be retroactive. Going back to the whole PAAS SAAS thing, when we patch the underlying operating system for you, you're fixed. If you've deployed some sort of an IaaS image with a vulnerability, and they go and patch the IaaS image that you built it from, your IaaS image is still vulnerable unless you go and update it yourself, right? And that's something I think people miss that because they said, it's like I said, it's the cloud. They got it taken care of. So 2018, as we found out, ransomware isn't very effective, right? It serves a purpose, I suppose, in trying to make money, but it's really noisy. It kills the host. People are going to notice it when all of their machines start screening and showing up with these skulls and crossbones and looking for for bitcoins. But crypto mining, on the other hand, is a really, really good way to try to make money surreptitiously. This is obviously coming across, they've switched the tactics on NoSQL. A couple weeks ago, Trend Micro, I believe, posted a blog talking about how attackers were going into CouchDB, and instead of dropping the databases and leaving a note, they were just loading up CoinHive mining scripts to mine Monero. And I ended up looking that up, found the database, added it to the script, so there was, within a couple days of them putting the blog out, there was like 1,700 machines across the internet that were mining Monero, and people probably had no idea this was going on. The other thing that we're finding too is I don't do the S3 bucket research, that's more Chris Vickery's thing, but people are starting to use open S3 buckets and dropping mining scripts in there, or finding out, I think the LA Times recently, they figured out one of their S3 buckets, they went in, dropped some CoinHive code in there, so anybody going to like read their news is going to start mining Monero coins for whomever these attackers are. And anything that's vulnerable at this point, the really interesting thing is we're in an age now where historically, stealing from someone involved intellectual property, right? I'm going to pirate your music, I'm going to pirate your movies or your software. Now, you can actually steal someone's resources in the sense of electricity or CPU time, and you can make money off of it, right? This was, not a lot of people are going to make much money selling pirated MP3s, but now you can just go and mine cryptocurrency, and obviously, and it took, what, a couple months for these guys to make $250,000 off of a few Oracle servers? I mean, at the end of the day, who's going to pay for that electricity, right? I mean, if you notice it and it's in a cloud subscription, you're going to say, hey, cloud guys, why is my bill 10 times what it was? Well, you got owned. That's an uncomfortable conversation that I absolutely don't want to be involved with. So to end on a less gloom and doom note, there is a bunch of things that me and folks at Microsoft are trying to do to make this better. Obviously, I've said, make sure you update your IAAS images. If you're going to use it and there's a need for it, just make sure when you turn it on, go through, do the Windows update or the apt-get update, any of the things that you can do just as you would if you were deploying a normal server. Look at the firewall settings. Make sure, like the security groups in AWS, the network security groups in Azure, you can fix them at any time, but it's easier if you just do it, make it part of your checklist of, you have to choose what size of VM and your credentials and all these other things. Make sure you look at those firewall settings because they weren't set by you, and you should at least be aware of what you're going to be exposing when the thing boots up. So yeah, remember that the third-party IaaS may be outdated. If it's a Windows image from Microsoft, it's going to be at most maybe 28 days old. So to this, I've actually started dialogue with people inside of Microsoft and with AWS. I think we need better visibility into the IaaS VMs, right? The stuff that I'm finding, I was surprised when I realized that nobody else had even looked at this. So right now, I've got the folks from the Azure Gallery are working on being able to give you, at least showing you the age, right? Tell your users when the last time this thing was updated, right? So if you see something that's 200 days old, you might want to choose a different vendor's solution. Oh, thank you. You might want to choose a different vendor solution if this thing's really old, and I think that this would serve two purposes. First off, it would let the users know, and I think second, it would sort of shame vendors into updating their IaaS images more frequently, right? If they say, oh, our subscriptions or our users from Azure have dropped down by this certain percentage in the last couple months, well, why? Because people don't want to spin up your old, outdated code. Okay, well, let's fix it, right? Do the right thing for your customers. The default firewall stuff, I'm working to try if we can force people to at least review it, right? Say, there's a few things like HTTP, okay, that's fine, we accept that. But if there's anything else, make them at least look, right? They don't have to change it, but just say, hey, you should be aware that, for example, there's 25 different VM images that expose MS or MySQL to the internet in Azure's Gallery, right? Why would you put a database on the internet if you don't have to? And then the final thing is being able to get the version information out of the VMs, right? So if you're spinning up a LAMP stack or an ELK stack, expose the version information of these processes. They're the daemons that are going to be running, right? So this will serve the purpose of users will know, okay, I know what version it's got, and then the next time something like Shell Shock or Heartbleed comes out, it'll allow the cloud providers to say, okay, let's do a quick database query against everything we've got. We find all the images that have X version of the vulnerable library, and then we either stop letting users deploy them or reach out to the vendors and say, hey, you need to update these right away, or we're just going to delete the things. And finally, I'm not a sales guy, but if you're running in Azure, I'd learned a couple days ago that Azure Security Center has a free tier offering. So you can just say, yep, look at my VMs, give me some security recommendations, tell me what's might be good, might be bad, and it doesn't even cost you anything if you're an Azure customer. So there you go. Thank you very much for having me. It's been a pleasure.